All right, we're going to start with this first circuit here where we have three resistors connected in series to a 60-volt battery. So I'm going to start off by just drawing the basic circuit. So there's our 60-volt battery. There's resistor 1, resistor 2, and resistor 3. So we have a 5 ohm, a 17 ohm, and a 25 ohm resistor. The first question they ask is, what is the total resistance of the circuit? And we know that when things are connected in series, we're just going to add up each individual resistance. So our total resistance will be 5 plus 17 plus 25, which gives us a total resistance here of 47 ohms. From that, we're going to be able to answer our next question, which is how much current goes through the battery. So we're going to be applying Ohm's law here. We're going to say V equals IR. Our total voltage for this circuit is 60. Our resistance is 47. So we can go ahead and divide by 47 to get the current, which ends up being 1.28 amps when we round it. From there, we can answer our final question, which is what is the voltage across each individual resistor? So what I'm going to keep in mind is this 1.28 amps is going to go through all the resistors in this circuit. So 1.28 amps is going to flow through the 5 ohm resistor, the 17 ohm resistor, and the 25 ohm resistor. And so based off of that, I'm going to be able to calculate the voltage across each of those resistors. So we'll start with the 5. So for that particular resistor, we're going to do V equals IR. We'll say our voltage is going to be 1.28 times our resistance here, which is 5. And we end up getting a voltage here of 6.4 volts when we round that. We move on to our next one, the 17 ohm resistor. And so for that one, same basic equation here. We're going to say it's just our current, which is 1.28, times our resistance, which is 17. And again, we're just using that Ohm's law equation each time. So we get that the voltage across the 17 ohm resistor is 21.7 volts. And lastly, across the 25 ohm resistor, same equation, the 1.28 times our 25, and we get that our voltage here is going to be 31.9 volts. All right. Do be aware that this 1.28 was slightly rounded, so these numbers that I have here were based off of that unrounded current, so if you got something a little bit different, that's totally okay. We could double check and verify that this works. If we were to add up these three, 31.9, 21.7, and 6.4, we should get 60 volts, or again, maybe due to some slight rounding issues, we might get something a little bit above or below 60 volts, but it should basically add up to 60 volts because we know these must add up to the total voltage of the battery. Moving on to our next one, we have a basic parallel circuit now. So we have 3 bulbs in parallel connected to a 9-volt battery here. We're told that each one of these bulbs has a resistance of 7 ohms. And the first question we're asked is, what is the total resistance of the circuit? When we're dealing with a circuit in parallel, we use the 1 over R equation. So 1 over that total resistance is going to be 1 over R1 plus 1 over R2 plus 1 over R3, and we could keep going if needed. But here we only have 3, so I'm going to say 1 over RT is going to be 1 over 7 plus 1 over 7 plus 1 over 7. We certainly could use some combine these fractions and do everything algebraically, but what I always like to do is just get a decimal answer for that. So 1 over 7 plus 1 over 7 plus 1 over 7, which is really 3 over 7, gives me 0.42857. This one is a little bit easier to do without doing this decimal way, but again, I always just do it this way, and then I don't have to worry about it when it's a little bit more complicated. We're going to take advantage of this x to the minus 1 button now and raise both sides of this equation to the negative first power. So we're going to do 0.42857 to the negative first power. That's going to give us our total resistance, which ends up being 2.33 ohms. All right. A quick little trick, just so you're aware, whenever you have ones that are identical, like we do here, if they're connected in parallel, you're just going to take the resistance of one of them, which is 7, and divide by how many you have in parallel. So if you just did 7 divided by 3, that would give you this 2.33. If there was 8 of them, you would do 7 divided by 8, and so on. Moving on to the second part, how much voltage does each bulb receive? That's actually just a conceptual question. Each one of these is on its own separate loop. We know that each loop, no matter what, must lose the full voltage of the battery. So if the battery is 9 volts and they're the only resistor on it, that means there must be 9 volts across each one of those. And then what is the current running through each bulb? It will be identical because they're all the same resistance, all the same voltage, so we just need to do Ohm's law one time. But we do need to do it once, so 9 is our voltage, equals our current times our resistance, which is 7. We go ahead and we divide by 7, and we get that our current here is going to be 1.28 amps. Alright, so for this next problem, we have two circuits here. Both have 12 volt batteries, a 12 ohm resistor and a 36 ohm resistor, but the difference is the one is connected in series, the other is connected in parallel. And we want to answer the same set of questions here for each one, and that is, what is the total resistance in each, the voltage across each resistor, and the current through each resistor. So for this first one, what is the total resistance? We know that when connected in series, that means that we're just going to add up the two resistors to get the total resistance. So it's just going to be 12 plus 36, which gives us a total resistance here of 48 ohms. So there is our first answer. Next, we want to know the voltage across each resistor and the current through each resistor. So what I'm actually going to do is, what we typically do is we find our total current using Ohm's law, V equals IR. So I'm going to say 12 equals my total current, the current leaving the battery, times my overall resistance, which is 48. So I get a current here of 0.25 amps. Now that ends up being the current that leaves the battery, goes around to each resistor. So they both have 0.25 amps of current. So that actually answers question C here for that first resistor. Each one gets 0.25 amps of current. And then we can go back and answer question B, what is the voltage across each one? Now that we know the current through each one, and of course we're going to use Ohm's law to find that. So I'm going to say V equals 0.25 times 12, which is my resistance. And so I get that the voltage across the 12 ohm resistor is just 3 volts. So that's for the 12 ohm resistor. And then the voltage for the 24 ohm or the 36 ohm resistor, 0.25 times 36. And so across the 36 ohm resistor, we have 9 volts of voltage. So there's the first circuit solved. Let's go ahead and move on to the second circuit here. So we'll start once again with finding the total resistance of our circuit. So in order to do that, we're going to do the 1 over RT equation because they're connected in parallel. And so we can say 1 over RT is going to be equal to 1 over 12 plus 1 over 36. Again, we'll do that math in our calculator and actually get a decimal answer here for that particular one. And so we get that 1 over RT is going to be 0.111 repeating. We're going to use that x to the minus 1 button, raise both sides to the negative first power. And again, that's the button on your calculator that looks like this. And so when we do that and we solve for our total resistance, we get that the total resistance of this circuit is going to be 9 ohms. Moving on to the second question, we're trying to find the voltage across each one. We know that in parallel, each resistor is on its own loop. We know each loop must add up to the voltage of the battery. So to answer part B here for the second circuit, it's just going to be 12 volts on each one. All right, because each one is on its own loop, so each one gets the full voltage of the battery. Moving on to our final one was the current through each one. For that, we will have to use Ohm's law, V equals IR. So we know that each one gets 12 volts. That's going to be equal to the current through each one times the resistance of each one. So we'll start with the 12 ohm resistor. When we solve for that, we find that our current through the 12 ohm will just be 1 amp. We move on to the 36 ohm resistor, I times 36, and we find that for the 36 ohm resistor, our current will be 0.33 amps. So there you have the currents for each one. Moving on to our final problem here, we're given this circuit right here, and we're told that the current through resistor A is going to be 0.5 amps going through that. And we first want to know what is the current through resistor B and through resistor C. And so that is going to be 0.5 amps because we know that that current will continue on through B, continue on through C. So all three of these resistors connected in series get 0.5 amps of current. Next question was the voltage across each resistor. For that, we're going to use Ohm's law. V equals IR. So we'll say for the first one, resistor A, V is going to be our current, 0.5 times our resistance. And so we end up getting 1 volt across resistor A. Moving on to resistor B, it's going to be V equals our current, 0.5 times our resistance, which is 5. So the voltage across resistor B is 2.5 volts. And finally, moving on to resistor C, V equals 0.5 times 3. So we end up getting 1.5 volts across resistor C. Lastly, it wants to know what is the voltage across the battery overall. And so for that, we keep in mind that each loop must add up to the voltage of the battery. So we say the voltage of the battery, that total voltage must be the sum of these voltages. So 1 plus 2.5 plus 1.5, and we end up getting that the total voltage, or the voltage of the battery, is 5 volts.